Good day, everyone. For this week, we're going to pick up and go over a couple point level analysis tools that we can use. Keep in mind, we've used quite a few of these already in different fashions, be it connecting or joining points to streets or to another layer. Going to go over a couple other ones today. With that, next week we're going to touch on more neighborhood and macro level, say county level information, and then get into raster data on the back end. But with that, let's just dive into it. The example I have up here in front of you is again Little Rock. I already selected out violent crime from 2019 in Little Rock from this attribute table here. I just did a select by attribute and did it based on crime type, and I just selected the violent ones there, saved it as a separate point layer. I also have our liquor source. So one of the tools that we've used in the past is a buffer. Simple, pretty straightforward when it comes to understanding a buffer ring or a buffer in general. You can also use your select by location if you just want to get a quick snapshot of how many points, lines, other features are within a certain distance. You can just do a selection of that. But you might be interested in, well, what if we have different distances we want to measure? So I'm going to go over an example of how to use that and how you can add in the area part to it as well. With that, all these points are in one layer, so when we do a multi-ring, it's going to come up as just one together. You can do individual ones, but for now, and the purposes of what we're going to cover in the class, this will cover a lot of project needs and necessities for what people want to do. So with that, we have our two layers that we're interested in. We have our liquor stores and we have our violent crime. And it's fairly common to want to understand, is there a relationship between the sale of alcohol off premises, so you take it truly like a liquor store, and different types of crime? This has been studied many times. This is just one way to assess it. There's no significance to it, but we can always add it in at a later time. But if we hop over to our toolboxes, go to our analysis tool, similar to where we find our buffer under the proximity one. If you go further down, we just have our multi-ring. If we open that, if you look at it, it's fairly straightforward. So our input features, what we want to make a buffer around, is going to be our liquor stores. An output class, that's going to a Geo database, which I don't want it to save there. You can see one that I was playing around with earlier. So I'm going to change this to a 4-block one and just add an extra one to it. Now here's our distances. This is where you can specify how you want, or how many rings you want, and it can be based on different units itself. Since this one I know is in projected feet based on the state plane, I'm going to stick to feet, and I'll do very standard, the 500, which a lot of older research uses. It's fairly common now to use your average street block as kind of a distance measure for that. Little Rock, it's anywhere between about 17 and 432 feet, depending on the year we're looking at. But for this one, let's just keep it pretty standard of going 500 to 1,000 to 1,500 to 2,000. So we're good there. We want to specify that this is in feet. It's going to make us a field for us, so it's going to be the add field part. Non-overlapping means that it's going to dissolve essentially the buffers that overlap for us. I'll zoom in and show you some of these. If not, you can have the overlapping disks. Keep in mind you can double count depending on what you're doing with it on the back end. Now if I just click run, it's going to generate that multiple ring buffer around each liquor store for us, just like that. So if we zoom in, give it a second. Oh, don't freeze on me. There we go. I just got a warning of not enough memory. But you can see here an example of how it would dissolve in our fourth ring, or some of the separate ones by themselves. So it would be 1, 2, 3, and 4 are our different ring buffers there. But here's where we can see, and we can then do a join based on our violent crimes to each ring buffer. When I say that, if we open the attribute table, it gives us our distance threshold here. So if I were to highlight any one of these, it's going to highlight those rings for us and show what that looks like here. The cool part is, if you want to get into it and understand, let me make sure I clear that as well before I add. Keep in mind, each ring there is going to have a different area to it. So we got to keep that in mind, especially if we want to compare how many crimes occur there. So for now, let's do a buffer area. I want to keep this a double, and it's going to be numeric. Good there. Click Save. Give it a second, shouldn't take that long. Now I want to clear, but now since I have the area tab, I can calculate the geometry of this one. So with that, it already has it pulled up, so I have buffer area, and I want this to be the area itself. You see the different options in here. For this one, only interested in the area. With that, the unit, I'm going to go ahead and do square miles for now. You can see the coordinate system it's already in. It's going to calculate that for us. So you can now see the difference in how much areas per buffer. So our inner one is our smallest one as we go out to our fourth buffer ring. You can see, and that's where we have some more joining going around it. We have a larger area. This is 8.5 miles versus 1.5 miles with that. But the cool part now is, since we have our distance identification, we have our area, we can join our crimes to this as well. So if I now do a join, I wanted to do a spatial join. The multi-ring buffer, join features, I want to join the violent crime. It's only going to be 1-to-1, so I only wanted to join one specific ring. And I'm going to say within, so this one specifies that the violent crime is within the target feature. Or should it be contained? Probably contained since I had it backwards. There we go. So the target buffer contains our violent crime. With that, I don't need a search radius. I don't need much else to it. Now, when we do join, you have the option to bring in some of the characteristics from the violent crime. With that, I don't need anything other than a count to it, so I'm deleting everything else with it because it's going to give me a join count number. That's all I need. So I have my buffer area, my distance, and click go. And now it's taking those points and identifying which ones are contained within each one of these 4 buffers. With that, I did not pay attention to where I saved it, so keep in mind, always do that. I kind of got ahead of myself, but if I open this attribute table, our join count here is the number of crimes itself. So if we want to, we can make a metric now per square mile because we have our area. We also have our crime counts over here. You can see as the distance increases, we do see a general increase up to about, if we treat this as each one's a block, to about 3 blocks out, and then we start to see a decline here. So this would make me wonder if I added another 5th or 6th ring to it, would we still keep seeing a decrease? So a distance decay the further we get from these liquor stores, we actually pick up less crime occurring at them or near them. With that, since we have our crime counts and we have our buffer area, this is where you can get into crime density. You might see that in some studies, anything with that. But for now, this is just a simple way to look at a multi-ring buffer, join point data to it, also bring in the area itself. So if you wanted to make a metric and truly compare them apples to apples, you can do that with this in front of you. If there are any questions with this, you'd like me to do a bit more with the actual crime counts and buffer areas and show how you can use these for calculations and see if there's a distance decay, let me know. I can always do another video, anything with that. If not, enjoy, good luck, and have a great St. Patrick's Day since this is March 17th. Alright, now I figured we'd get into a couple different spatial analysis tools Some I use more regularly than others. A lot of this can also be done if you have a point file that's projected. Go into CrimeStat 4, the most recent one, I think it's the last one in the series. Free download through National Institute of Justice. Pretty handy program that does a lot of spatial stats. Just not a lot of people use it. It is user intensive, but once you get the hang of it and what it's doing, it is a very valuable data program software for crime analysis. With that, I'm picking up from the last video that I just made on using a multiple ring buffer, but I still have the violent crimes showing up here, so I figured we'd go into our geoprocessing toolboxes again, but we're going to go to the bottom of this one. If you go down here, and this is where the next couple of weeks we're going to be spending quite a bit of our time. If I hop down and just go into our spatial statistic tools, and you have a lot of options here. This is where you become familiar with it. We're going to do a lot with these depending on the unit of analysis. A cool one that I've used time and time again to see how close or how near things are is the average nearest neighbor. If I hover over it, you can see it's calculating a nearest neighbor index based on the average distance from each other features. So at this point, I'm interested in the average nearest neighbor for violent crime. So if I double click it, I want to know what the average nearest neighbor is, which gives you an idea of how close these violent crimes are occurring. You can see that just at eye level, they're not randomly distributed across Little Rock as a whole. There are clusters within it. And when we get into raster analysis or even some of the neighborhood level, meso level, we'll get into some of this and how to display it. But visually, if you were thinking old school pins on a map, you would start to see clusters just based on this itself already. This is probably taking a bit to open because I honestly do not remember the last time I opened average nearest neighbor. But with that, I have my violent crime. And it gives you a couple different options here, Euclidean or Manhattan. Euclidean's straight line, Manhattan's across X and up on Y, or whichever way you're going. There's plenty of research out there that compares the two, and even some of the newer ones with street network analysis in it. I'm going to stick to Euclidean. I prefer to generate a report because that actually shows you a bit more material with it. I'm not interested in anything else. It gives you an option here for an area output for it. For now, I'm okay with it. This is typically what you would do for your area of Little Rock. If you didn't know your boundary in the area of it, if you went into your attribute table, so this one has it in square miles, 122, so I could put it up here for us. If I wanted to do 122, it would be in square miles, but for now I'm just going to do default, nothing there. Go ahead and click run. Then once this one is done, it's going to generate a report for me. So I just hit view details so I can click on it once it's done running. Now it's completed. It's generated a report. Open my history if it will come up quickly. And come back to me. And give it a second, it's trying to load through an HTML for it. And if you're wondering where I ended up clicking, so when I'm in history, if I hover over my average nearest neighbor, it saved it down here into a Little Rock Hub for me, and it's going to open, you can see at the end, the extension is an HTML. So give it a second, we'll see, there we go, where that pops up. And it came over on another screen, so let me drag it over for you. Here we go. So what it pulls up is a pretty cool table for you and identifies it's a clustered and gives you the z-score. The higher, the more clustered it is, either direction for it. So you can see here what that looks like, and this is where it's important to where you should put in your study area at a certain point. Mine was in square miles. You can always change it to get your square feet to put in here for it. But you can see our average nearest neighbor expected would be about 775 feet, but our observed was under 200, 178 feet. So it's significantly closer than what would be expected by random chance. So with that, it's a nice tool to have to look at just simple clustering in terms of nearest neighbor average itself. You can see based on the z-score, it's pulling it for you, so you don't have to look up your critical values and go into that lovely ordeal. But with that, it is a good display and kind of show as a descriptive, what does your data look like before you get into some more advanced analysis. All right, let's keep the ball rolling with our Little Rock violent crime example. In the prior videos, did the multiple ring buffer, did an average nearest neighbor, and now I'm going to get into what I refer to as almost spatial descriptive statistics that I honestly have tried to publish with a few different times in the past few years, and reviewers just hate it. It's probably based on how I'm presenting it, but I think given how much attention is given to descriptive statistics for non-spatial research, this deserves a bit more of a look over. And with that, I'm probably a little biased because I use these for my master's thesis, but it comes down to, or relates to, an article by Dr. Jim LeBeau. He was my master's mentor advisor back at Carbondale, and it's using centrographic measures of central tendency. I'll get into this in another video, kind of comparing it over a couple different years, but I think it's a cool way from a descriptive standpoint how to describe our data, say at a city level. This is what helped me understand some spatial stats terminologies, or just statistics terminology in general, is the ability to see it. So I'll go over that. I'll discuss that when I have a bit more time to get into it. Hopefully I can get it published at some point. It is a cool article that's in quantitative crime. He was looking at serial rapists. Similar, or another note, if you're interested in kind of the journey to distance to event, I'll touch on that in the future, but for the most part, if you have an XY coordinate of a crime or event location and a home location or a starting point, you can do a distance analysis. You can do that in Excel, you can do it in here, you can just, it's pretty straightforward to get a Euclidean distance, a Manhattan distance, or a street network distance with it. With that, it's a bit difficult given when we do it from a crime standpoint, we oftentimes use a home address for just general anonymity. I'm not going to get into displaying home addresses for known criminals or crimes itself, but there is a lot of research out there. I'm getting into it a bit more and analyzing journey patterns for it. But with that, let's get back to some point level descriptive statistics. So as you can see here, I still have open from what we just did with the average nearest neighbor. I'm going to pull this over just so I can see a bit more, but that wasn't the issue, it was that. But if you look here, we have quite a few different tools, and even the one above it, the spatial analyst tools, you can see that there's actually a lot you can do. So this is where I say you could spend a lot of time, and we'll use some of these here in the near future, but spend some time going over these. This is important to become familiar with. But with that, this is kind of the cool part where I did a lot of work with my thesis and looked at the standard deviational ellipse change over time, the circularity, coefficient of circularity, and what that means for a distribution of crime within it. Like I said, get into it, but this is a pretty cool way to display some of your data. So with that, we're going to get a standard deviational ellipse. We're also going to get our mean center, and that you can generate a couple different mean centers, especially if you're getting into crime stat. But for now, let's just get into a simple ellipse itself. So if we think about it, a one standard deviation ellipse is going to capture about 68% of our crime. Here, we're still going to focus on violent crime itself. So let's input that and output ellipse class. I'm just going to save this to the tutorial folder because the last couple times I didn't, and it got me in a bit of trouble. So violent crime, standard deviation ellipse, Little Rock. I'm going to save that. And here you can see that it has a couple different options, how many standard deviations you want to go up to. For now, I'm going to leave it as 1. If you want to weight it based on another field that you have, for us, it's just the location itself. If you wanted specific types itself, you could do it that way. I'm keeping it to violent crime. I'm going to click run. And it's going to generate that standard deviational ellipse for us. And it's going to appear probably right in this area, would be my guess. give it a bit more time to calculate the lovely results and generate that ellipse for us. I'll click pause just to save a bit of time. And there we go, is added to our contents for us here in our bright pink, so you can see just where that standard deviation ellipse is. I'm going to move it just on top so it is on top of everything. But keep in mind, since we're looking at a one standard deviation ellipse, this is going to capture about 68% of our crime. Again, it doesn't tell you where within the ellipse it's occurring. So if I turned off the crime itself, we wouldn't know where in this ellipse crime's occurring. We just know that ellipse contains about 68% of the violent crime for calendar year 2019 in Little Rock. Pretty cool, and it is fairly close to being a circle versus more ellipse shape. So the coefficient of circularity would be closer to 1, saying it's more clustered, which, not shockingly, if you look here, speaks to this corridor in here between the two interstates, which we've done a fair amount of research on and continue to get into it now. But with that, that's cool. Well, it would be nice if we had a mean center as well for our standard deviation ellipse. So with that, if we just go back one and hop down to our mean center, going to input the exact same violent crime, make sure it's saving it to where I want. Base, it's not, it's going to a hub. So violent crime SDE, I'm just going to put, for this one, MC for mean center. I'm good to go there. I don't want to weight it. I don't want to have a specific case. I don't want a dimension field for it as well. So with that, I can go ahead and just click run and let that run in the background. You can see it is the center of our ellipse. So you can see here this is our center point. And you can even go from here if you want to do the nearest violent crime to this point to see how that changes over time or over different distances and everything with that. It's a pretty cool feature. But from a centrographic measures of central tendency, everything with that, you could look at this over different weeks to months to years and see the shift of the mean center and the change in directionality, if it's east-west, north-south, which way the ellipse is being pulled, can speak to a change in the underlying distribution of crime. That's why I like it from a spatial descriptive statistics, but people don't really display this. It's kind of brushed over. They don't think it adds much, which I get. But we still have the habit of making a descriptive statistics basic table. It's expected. From a spatial standpoint, we really don't get into that other than saying how many crimes occurred during a given time frame, what our geocoding rate is, anything with that. But this is a pretty cool, I think, cursory level analysis just showing a distribution of crime within a city or any jurisdiction with it. So it lets you have a feel for where crime is occurring. Based on this, and if we did let me open this, and so this is all the information you honestly need to use in your centrographic measures and the central tendency stuff. It puts it right in. It's actually fairly straightforward. But with that, we could do a quick area. And that's going to be a double. And I'm going to keep it as a numeric. Hit save. Hop back over here. Calculate the geometry. And I'm going to make sure it's square miles. And what I'm interested in now is, since this is capturing about 68% of all crime in Little Rock, if you notice though, it's about a fifth of the area total. It might not look it, but if you keep in mind, if we open up the Little Rock boundary again, and we have our square miles here, 122. So if I hop open the calculator, 122 minus 37, it's about 85 square miles that's not covered in this ellipse. So then we could do some just basic comparisons with crime counts. We know that ellipse has 68%, so the other 85 square miles has about 32% of the violent crime. So if you keep that in mind, it's it's a pretty cool descriptive tool to use. I'm not saying it's always important to use, but I think this is needed in more research, or at least discussed, because it's just glossed over and a lot of people honestly don't really use it. I haven't seen it in any paper I have reviewed, so I highly recommend adding this into it just from a learning standpoint, because for me, when it came to understanding a standard deviational ellipse and the 68% and the mean center and the mean values and the trade-offs for that and the change over time and everything with it, and just understanding more basic statistics in general, spatial made sense to me. That's why I've kind of stayed in this area. But if there's questions with this, let me know. This is a pretty straightforward way to get our mean center and standard deviational ellipse.